Alright, so here I'm going to show you how to use the Desmos calculator to find your line of best fit and your curve of best fit. So I find this actually more intuitive than the scientific calculator just because I can see everything on one screen. I can manipulate things with things that I know, zooming in and zooming out like this, rather than having keystrokes to remember. So I would recommend that you learn this, especially since in future years, I think the Desmos calculator will be mandatory for you to use during the SOL. So, the first step is actually really similar to the scientific calculator. First, you just need data, which means you need a table of points. If you start typing the word table, a table will pop up with x1 and y1, and then you enter your data there. X is there. I'm just making up random values. They're not totally random. They're generally going to follow sort of a line. So now I zoom out just so I can see my points. On the scientific calculator, you need to make sure that the plot 1 is highlighted so that these points are actually being plotted, and then you have to hit zoom stat. That's just more to remember than just basically zooming out to see the points. All right, so that's our data. Now from here, I want to make a line of best fit. So I'm going to go to the second cell and ask it to approximate an equation here. So I want it to approximate an equation for y1. I'm going to say y and then the tilde symbol. That's just to the left of the 1 key. And then I'm going to type in ax1 plus b. And you should really notice that that is the slope-intercept form of a line of best fit. So we have our correlation coefficient, we have our constant, and basically that's a slope and a y-intercept. And you can see that purple line show up there. That is our line of best fit. If I wanted to write that out, I would write that equation, I'm going to round to, let's say, the hundredths place, so 5.11 x minus 2.07. That is my line of best fit. That shows this equation that cuts through the center of that data. I'm going to use the exact same data and now come up with my curve of best fit. So a line of best fit is basically just slope-intercept form. A curve of best fit is a quadratic. So I'm really just going to change this equation around just slightly. I'm going to add the square that comes with every quadratic. I'm going to add the additional x term plus the constant, which is now going to be called c. And you can see now I have my quadratic that maybe even more closely fits that set of data. So really the key part is that you understand what you're typing in there. This y1 is talking about the data points from this table, y1. These x1s are talking about that x1 in the table. And really you're just giving it the standard form of a quadratic or a curve of best fit, or the standard form of a line, which is the slope-intercept form. And now this a, b, and c here, that's how I'm going to actually write out my equation. So I'm going to use y equals, that's my a, or my leading coefficient. I'm going to have to write this smaller. Y equals 0.0, I'm going to do the hundredths place again, 55 x squared plus 1.24 x plus 3.10. That is my curve of best fit. When you're asked to make a prediction based off this curve, you can plug in any x value and find the expected y value. So it might not be according to the data, so you can actually plug in, let's say 4. If you plug in 4 there, you might not actually get 17. You might not get this piece of data, but you're going to get something that's basically according to this line of best fit or curve of best fit, what is expected based on the rest of the data, which is where this equation came from.